All right, hi boys and girls. We're going to watch a brain pop video about gravity, and hopefully we'll learn some more cool stuff. And here we go.
Ow! Well, you didn't have to drop it on me. Dear Tim and Moby, how do we stick to Earth? Why don't we just fly off into space? From Chrissy. Sometimes I wish Moby would fly off into space. Yeah, whatever. Now, let's talk gravity. When Moby let go of that apple, it dropped towards Earth and hit me along the way. For thousands of years, philosophers wondered why this was so. Did Earth have some special quality that attracts all objects? It took a certified genius named Isaac Newton to figure out the answer. He reasoned that there was nothing uniquely attractive about our planet. Instead, a force called gravity made all objects behave this way. Everything in the universe has gravity. Earth, the sun, the moon, apples, even you. Newton proved that you could calculate gravity's pull with just two things: mass and distance. Massive objects exert a stronger pull than less massive objects. And objects that are far apart exert less gravitational pull on each other than objects that are closer together. This thinking satisfied scientists for more than 200 years. But then Albert Einstein came along and expanded on Newton's ideas. Good going, Einstein. Einstein wondered how gravity really works and why it depends on mass and distance. In his general theory of relativity, he showed that mass actually bends space. The more massive an object is, the more it bends space, and the greater its gravity.
Okay, that's freaky. How do you bend space? All right, but that's pretty cool too.
Yeah, it's hard to picture how space can bend, probably even for a brainiac like Einstein. New scientific theories often raise more questions than they answer, but you can think of it like this. If you put something massive on a trampoline, like a bowling ball, the surface sinks in a little.
Oh!
Put a smaller object nearby, like a marble, and it rolls toward the bowling ball. Kind of like how Earth orbits the sun. Well, it's...
Now that's pretty cool. So you have something heavy in the middle of the trampoline, and then you start something orbiting, and the way space is bent makes it pull in. Oh, that is crazy.
not a perfect analogy. But don't worry, in real life we won't fall into the sun. Back to our question, Earth's gravitational field pulls you toward the center of the planet. Since all objects possess a gravitational field, you're actually pulling back on Earth. But your pull is
an equal and opposite reaction. It pulls us, we pull back.
So much weaker, it doesn't make much difference.
Because we have so much less mass, right? So our pull is so much weaker because our mass is so much less.
An object's mass isn't the same thing as its weight. Mass has to do with the amount of stuff in an object.
Now, this is really important to think about here, the difference between mass and weight. In science, I try to talk about mass more often than I talk about weight, because when you're measuring the mass of something, you're trying to find out the measure of the amount of matter that is in that thing. Just like he just said, the amount of stuff, the amount of matter that's in the apple, that would be the mass. Now, weight is different because weight depends on the gravitational pull of the planet that you're on. So for instance, you've probably heard how when people went to space, they weigh only about 2/3 of what they weigh here on the Earth. That's because the moon is less massive, so it pulls less hard. Weight and gravity go together. If you went to Jupiter, which of course you couldn't, you would be pulled so hard that your weight would be ridiculously high. Now, does that mean that you get fatter when you go to Jupiter or skinnier when you go to the moon? Absolutely not. You still have the same amount of matter in you, right? Mass is all about how much matter's in you. Weight depends on the planet or the object upon which you are attracted. Right? If you're attracted to something that's really big and really massive, it's going to pull harder on you and you weigh more. But literally, you have not changed your mass at all. It's weird too. All right. But If you can keep straight that the weight is depends on gravity, but mass does not, that should help. So weight is all about the gravity, and mass is the same no matter where you are.
And weight is the force exerted on an object's mass by gravity. On the moon, an apple...
That was kind of nice. That weight is the amount of force exerted on an object's mass by gravity. All right.
Apple weighs 1/6 as much as it does here. It's the same apple, but the moon...
Oh, I said 2/3, but 1/6 is right. Sorry, y'all.
The moon's surface gravity is weaker because the moon is only 1/6 the size of Earth. Weaker surface gravity means that astronauts can jump 6 times as high on the moon as they can at home. The moon's gravity pulls at Earth, causing the ocean's tides. Earth's gravity keeps the moon orbiting around it, and the sun's gravity keeps us orbiting it. Gravity even holds planets.
Now keep in mind, gravity is what holds us around the sun. Gravity is what holds the moon around us. And the little part that they just said about the tides, we're not going to go into that too deeply, but you can see that depending on, let's watch the moon go around.
The moon's gravity pulls at Earth, causing the ocean's tides.
Right? So you can see why it might make the ocean pull toward it more when at different places when the moon's going around the Earth. Right? Tides change 4 times a day. There's 2 high tides and 2 low tides every 24 hours. So every 6 hours, right, then it changes the tide as the moon travels around the Earth. And what I mean by that is when you go to the beach and you walk on the sand when the ocean's way far out, that's low tide. And then sometimes when you go to the beach and the ocean's really close to the hotel, that's high tide. And that all happens because of the moon. It's pretty cool.
Earth's gravity keeps the moon orbiting around it, and the sun's gravity keeps us orbiting it. Gravity even holds planets and stars together. It's one of the most important forces in the universe, as far as we're concerned. Without it, we wouldn't even have a planet to stand on. Moby! Ah!
All right, that one really made me laugh for real. All right, we'll stop for now.